Hey, welcome back to another one of my YouTube tutorials. We're going to be starting with the results of the previous sand grain disintegration simulation tutorial and bringing it into Redshift with Houdini, starting to light things, starting to render everything, using instances, a few different shaders and stuff like that, and pack primitives to make a really nice looking kind of high detail, high resolution result. So just starting with our original setup, we're just going to branch off over here and start developing our Redshift packed primitive instancing approach, getting a lot of little details propagated across the particles from our base simulation, and basically going through some of the research and documentation that Pixar has provided from their technology behind Piper, their short, where they did a lot of development and very nice write-up about how their approach to rendering sand grains using instances and different shaders, different geometry, sculpting it, getting really nice detail up close. So I hope you're ready we got a power-packed hour and a half, boost your Houdini skills, boost your tool set, and I hope you have a good time coming up. I'm picking up where we left off at the end of the grain character disintegration tutorial. Just looking at the results from the end of that video. And one thing that was sticking out a little bit to me is just the character's form before he starts crumbling or disintegrating. Looks a little bit too clean. It's like too polished. If we're saying that this guy's made out of clumpy dirt or sand or something like that, it doesn't really make sense for these clean creases and like little intricate details of his fingers to be represented that well. Like you would expect this to be sand or clumps like packed together pretty roughly. So we want to make it just look a little bit more organic, and we want to break up this outline a little bit so it's not so perfectly clean and straight. So we can do that if we just go up to the top of our scene graph. We just kind of walk through a little bit. We were importing the character motion capture information and then just doing a frame hold or pausing the first frame to remove the time dependency. You see this green little clock means every time you change the frame of the scene, everything below this node will require to be recooked, but this removes that requirement. So all these operations here only have to be calculated once. It just makes your scene perform quicker for animations. And then looking at this convert to VDB, there's one thing that was brought to my attention is when you reduce the voxel size to try to produce a higher resolution volume, you run into this issue, the artifacts, because the geometry isn't watertight. So at higher resolutions, the volume conversion starts to cause errors, which are produced by this issue of just the hand isn't connected to the sleeve. Quick workaround for that is if you use the polyfill node. This is a really nice node that Side Effects made that just seals all of those air gaps. So now the geometry is watertight, or it's easier for that VDB from polygon node to produce the expected outcome. So if we run that again, now you can see even at the lower voxel resolutions, the lower voxel sizes, the higher resolutions, we're able to still get predictable results. And then if we want to get rid of this faceting, you can just subdivide the geometry before converting it to a VDB. So that just smooths out the topology, makes it a higher resolution. And then if we want to fix the issue with like his fingers just being a little bit too skinny, we can do a VDB reshape SDF. So this is a better operation to kind of expand or inflate your character when he's a volume. As these fingers expand, we can just dilate him a little bit more. The actual end result geometry, when we convert back to polygons, these will be connected now. If you did this using a peak node or inflated him when he was just a mesh, these would still be penetrating, so it would be more problematic kind of geometry. But doing the reshape to inflate, this is a better operation to perform over a volume. So now he's looking a little bit chunkier, a little bit thicker, and then we can just go ahead and, using the mountain node, this is nice to be able to use a procedural noise to displace geometry. So right now this settings, the height, the element size is really out of whack. We have this funny looking gremlin ogre or an orc or something like that. His legs, he's got little toothpick legs or something like that. We can reduce the height. This is how much you're going to displace him. And the element size is just the size of the little shapes that are going to be produced by this operation. So if we want smaller details, you can reduce the element size. Now we have a bunch of little spikes. And then if we just reduce the height, we just have less amplitude of our displacements. You can also middle mouse button, click on these parameters, and then you have the nice different precisions you can do, like different step sizes. And then if you drag left or right, you have a lot more control over changing these values at really small increments. So maybe this 0.099 might go a little bit bigger. This just lets you get really precise when you're selecting your values. So something like this is starting to feel pretty cool. It's definitely a lot more organic now. It's less uniform or symmetrical. We have some nice clumps and stuff like that sticking out. I might just use this ladder again here. One thing I've found is that if you go past 0 into the negative numbers, you're kind of inverting the results, or you get a little bit lumpier result instead of like spikiness. So now this might be a little bit more like clay or something like that that's been packed together, and just less rough. So instead of the bumps, the little spikes pointing outwards, now they're pointing inwards. We go into negative numbers up there. And then when we film with grains, you should see the result is a lot better. We have these nice little details kind of sticking out. We get some more interesting self-shadowing and stuff like that, and less of just like a boring, smooth shape overall. We could even reduce the grain size. So we're at 0.006 right now. We could go down to 0.005. And what this does is we're just going to be filling him with more grains overall. So now we have a little over 1 million, and we just have more detail to represent those little features and stuff like that we were adding with the mountain node. The last thing that might be nice to fix is, now that we've displaced him, some of his feet are going like through the ground. When we go into the simulation, he's going to start already going through the ground plane. So if we want to fix that, we can just use the clip node. I'm going to do that before we deform him. And what this does is just deletes the particles that are beneath the ground, or basically the direction. So right now it's just set to 0, 1, 0, so it's positive y. So anything less than 0 in the y direction is deleted, anything below the ground. This is just nice to solve this issue before the simulation. If you let the solver try to figure it out during the simulation, it can just try to shoot particles that are starting out underneath the ground up, and then that creates a lot of already like explosive problems and stuff like that. So just fix that issue before you start the simulation. Then if we go into our simulated network, one thing we're going to want to do is probably increase these substeps. So as we increase the overall number of particles, increasing the substeps to allow the solver to figure out more of the little collisions and stuff like that. Otherwise, I was saying earlier in the previous tutorial, you'll get some just instabilities in the simulation if you don't have enough substeps to resolve all of the behavior between each frame. And under the Advanced tab, I'm going to increase this attraction weight. So this, we were adjusting it to change the control of the kind of stickiness or clumping of the grains. So I'm going to increase it to try to get stuff sticking together and holding together just a little bit more. So as this like new details and stuff that we created, as it rips off, it should look a little bit more interesting with more clumping. And then with our file cache, if we don't want to overwrite the previous results, you can just modify this file name. This is based off of the geometry file here is based off of the node name. So $OS is the operator string. So if a middle mouse button, you can see it has the node name embedded in the file path. So if I just go ahead at the end here and I could just make this a new version, just call it a new version by adding .v2. Now if I middle mouse, you can see it has that. It will make a new folder for this version. And it looks like the frame range here changed because we adjusted when we went into slow motion. So I'm just going to delete the channel and set this back to 240. That's what our original frame range or simulation length was. And then we could just save this to disk, run the simulation. So this is going to be a little bit slower than the previous simulation. We added some more substeps and increased the particle count. So the solver is going to take a little bit longer for each frame, but it shouldn't be too bad. Just let this run again. I'll be back in a little bit. The simulation is complete. Now we can move the display flag to the cache results and start to scrub through. So we're doing the retime to slow down everything, just add a little bit more interest, kind of slow everything down to make it a little bit more impactful. And then the last node, we were just doing copy to points to add spheres to the grain particles. So these inherit the p-scale value and just visualize the little grain particles. Also the lighting, it makes it easier to evaluate like the self-shadowing of these shapes. So we can see the kind of clumping looks a lot better. He looks a lot more organic, and the little deformations of the surface help break up the like really smooth form we were getting earlier. So everything feels really connected. Now it doesn't feel like a separate material or kind of physical property that was representing him. Before just seeing the smooth creases, it didn't really look too much like sand or anything like that. So our simulation and form, the shape of everything looks great, and now we can move on to rendering and lighting. So if I go up to the object level, I can just control click on the camera. This is going to make a camera node from the current viewport orientation. You can use this little gizmo, kind of works like a cameraman, like dolly, truck, and all that stuff. So I'll just frame him up a little bit better. And with this camera, you might notice it added the Redshift camera parameters. So I have the Redshift plugin activated right now. So all of the nodes I create, it will add those Redshift parameters. But with this geometry character, so this is from the previous tutorial, I didn't have the Redshift plugin activated at that time. So if we want to add Redshift properties for the geometry container here, you can just go to the Redshift dropdown and do add obj parameters. So you can see it added the extra parameter tab there. And then this lets you have a lot more control over how this geometry or this object gets rendered. So under the particles tab, we could enable render object as particles. And then if I double click to go inside of him, we just want to change this display flag and render flag. We don't want to render these sphere primitives because these don't get understood by the Redshift renderer. You just want to send the actual points or particles to the Redshift renderer. So if I hold down the T keyboard key and click on this time blend node, this moves the purple flag over to this node, and that's the render flag. So the output of this node will be sent to the renderer, and then the blue flag means the output of this node gets visualized or sent to the viewport. So this is a handy way of doing like kind of two different outputs, moving these flags around. Then if I go back up to the object level, The light that we have right now isn't supported by Redshift. This is a standard Houdini light, so we can just delete that. We were just using it to visualize our simulation results previously. And if I just press tab, I can type in RS, and then you can see we have all of our different RS lights. And we'll get started with the RS light dome. So the dome lights, kind of all renderers support them, and what they do is they take a dome map texture, or it's like a standard environment light. These work basically using an image map. If we look here, this is kind of a explanation or documentation of how these maps are captured. You basically photograph a mirror ball, different exposures, and then merge them all together to have a high dynamic range, or basically these pixel values go above 1, so you can use them to light your geometry. And under my website here, johnkoons.com/resources, I have like geometry, little test meshes or scanned geometry, a bunch of different HDRI links. These will give you free HDR textures or IBL maps. All of these terms that people use is generally the same thing, but you can it just helps you get started here. You don't have to hunt around too much on your own. So there's like different little locations or times of day or lighting conditions that you can try out, and it's really nice to have these as like a starting point when you're starting to move into rendering and look dev and stuff like that. So this Playa Sunrise is a pretty cool one to get started with. We're going to say this character's made out of sand, so we'll just try him out in a desert and see what it looks like. I've already downloaded that texture map, so I can just paste the file path into this dome map parameter, and then you can see he comes up in the viewport as the background. And then if I go to transform, we can move the Y rotation around if we want to change the angle of the sun. And then there's one thing we need before we actually render, and that's just a render node. So if I go to the out context, this is where you put all of your render nodes. I'll just make a Redshift render. And if we click on the Redshift render node, then we can go to open render view. And then this play button over here gives you an interactive preview render. So pretty quickly, it's a GPU render. Everything's really quick and responsive. We can see the lighting results. We haven't assigned a shader to the character yet. So it's basically just assigning a default plastic shader. I can continue to rotate this around if we want to play with different sun angles. We're kind of stuck with this time of day, like all of the information and stuff like that is baked into the texture. You don't have a lot of control over it other than just rotating it, changing the intensity, maybe doing some tone mapping or gamma adjustments and saturation and stuff like that. Everything else is baked in, so you don't have a ton of control over it. But just to try out different scenes and settings and stuff like that, it's a useful way to work. So you go back to this camera, move it in, just try out different compositions or look at different areas. You could see the Redshift renderers basically doing the same thing that our viewport's doing, and just copying little sphere primitives onto the particles at render time. We're going to get started making some improvements to our rendering process. And one of the references or reading materials I found really helpful when I was going through all this is this breakdown of the tech that Pixar developed, or the approach that they took when they were creating this Piper. There was a short animation that they produced. And they had this little bird that was walking around a beach with like macro close-up photography of it. And to get the detail and realism that they wanted to in the sand, they ended up actually modeling individual grains of sand, a few different variations, and then randomly distributing them or instancing them across the entire beach to create a nice kind of representation or feeling of sand. So they found that this variation, not only in model, like little different shapes, but also doing different shaders to get hints of just different lighting responses, different colors, they found that that really helped them get really close to reference photography. So we'll try to kind of recreate that approach inside of Houdini. And we'll just go back inside of our man geometry container. So we're back in the geometry context. We have the SOP nodes. We can just make a sphere over here along the side of everything, kind of in a separate, start of a separate chain. And then I'll go into the headlight mode to get rid of the lighting and just press spacebar G to rehome the scene around this sphere. So right now it's the primitive data type. It's just one point. It's the basic simplistic representation. If we actually want to model something, we want polygons representing this. Maybe go into the wire just to visualize the topology a little bit better. So we'll add some more resolution or edges. And then we could just start using that same node we used to distort or deform our character. So this mountain node is really good at just generating kind of realistic noise patterns. One thing we can do is this noise type, instead of just staying with the default simplex noise, these other noises will give you different results. You can achieve different kind of materials or different kind of rock types with it. I think this whirly ended up working pretty good for sand, kind of sand grains. You change the element size and maybe go a little bit bigger. And then right now you can already see we're getting a lot closer to some of these shapes that they've kind of created. So something like this has some sharp edges and then smooth, flat areas as well. So that variation, I think, helps you kind of mimic a sand grain. This kind of thing, if you do research into it, like it's just been rolling around in the ocean, scraping up against things, over time just getting chiseled away into this like smooth angular form. So doing this whirly noise I found is a good way to replicate that. And you can start to stack these mountain nodes. If I just hold down Alt and click and drag on it, then I can get a second mountain node, and we could switch back to simplex and then maybe go to a smaller element size and a smaller height or amplitude. So just use this if we want to layer on a second layer of detail or a second layer of the disturbance or deformation to things, just to make it a little bit more interesting. You can play around with this stuff. It's maybe go back into the negative range for things, maybe changing the element size as well, just getting whatever you think looks good to you. So I think this is a good starting point. And then we can just click everything, hold down Alt, and drag it to make another duplicate of that same SOP chain. And we can go in here again, maybe change these offsets. This is kind of like just giving you a different random outcome. So we're setting up a procedural approach to creating these grains. This allows us to just very quickly go through and generate another random variation or another random outcome. If we want to, we could also just play around with this element size and very quickly just get different styles or different results. Maybe we want one with a little bit smaller element size, and then we'll just keep it a little bit more spherical. And going with this second layer, we could start to push things and make this one just spherical, but then a little bit rougher. I'll just make another variation. Maybe this one is pretty big element size, pretty big height. I don't know about this. It's getting a little bit too pinched in that area. Something like that seems to be. You want to make these like different enough from each other that they have different like profiles and different silhouettes, but not too different that they like would exist out of different materials or in a different universe or something like that. And then with this second layer of noise, maybe this one's a bigger element size, and you want to be careful looking for these blue edges. That basically means you're seeing a back face. You've pushed the mesh through itself. When you get these sharp edges and then you do another level of displacement, it's easy for it to kind of invert on itself. One thing you can do is this attribute blur node. And this will smooth everything. You can see here it's kind of relaxed the edge a little bit. You can do some more iterations. This is a good technique too, just for kind of sand, like the grain weathering. Over time, as it's getting knocked around, it just becomes a little bit smoothed around the edges. So now we've avoided that crease getting pushed in over itself. So this will be our fourth grain variation. Maybe this one. This thing right here is already feeling pretty nice. And if we're getting a lot where it's pushing in on itself, we could either just try to find a different offset area that works better, or also playing around with this element size and height just to get something that doesn't have any artifacts like that. We'll do one more. So we'll get started with 5. I think that's good enough to get started. If we need more, it's always, you'd see how quick we're kind of blowing through these. We might do another one that's a bit more spherical. Just the more that you reduce this element size, the more spherical they become. So something around this this size feels pretty good, and maybe just a little bit less height. And maybe this one I won't do that blur process. It's already kind of smoothed around the creases. And with this element size, I might go pretty small, and I might do one we'll just flip it around and go into the negative area. So the negative numbers is good to get it pushing in on itself and get little like divots, like other stuff has been bumping up against it and creating those little inward facing spikes or whatever. I might go a little bit higher just to get it a little less uniform. So now we have our 5 different variations. If you click through some of them, you can see the size of these might change quite a bit in the positioning. Some of them are a little bit bigger than others. So this is something we want to kind of normalize or make them all the same. So similar to like when we were doing the relative to bounding box in VOPS with the first tutorial, the simulation tutorial, we can do a somewhat similar process here using this match size node. So right now by default, it's just going to move everything to the origin. If you apply scale to fit and uniform scale, it will make it so that the largest dimension or the largest axis is constrained to be inside of this box. Uniform scale just means it won't distort it, like it won't squish or stretch it. And what we're going to be doing is putting this onto particles, or we want them to be the same size as a standard sphere, because that's what we were copying onto the P scale. So if we just plug this sphere in, it will match the size of the standard Houdini sphere. Or this is the same size as a standard Redshift particle as well. So we want the end result of our models to be that size. I can just hold down Alt and drag this match size. We can keep the same sphere plugged into that second input and just keep moving along and very quickly getting all these lined up. This is something nice. In other software packages, you might need a script to adjust the size, but I like Houdini. You can do a lot of things you would need, like Maya script or Mel or Mac script, just to do things visually. Now we're going to take a look at how we can take our different grain model variants that we just created and distribute them efficiently to a set of points or particles to represent a bigger data set. So if you remember at the end of our previous session, or to visualize the simulation, we're using copy to points to just place a simple sphere onto our simulation. We could start with that approach. I'm just going to use copy to points again. So again, you do the geometry you want to copy, and then I'm just going to make a sphere, and I'm going to grab this and do VDB from polygons. These VDBs are my favorite part of Houdini. It's a really powerful part to use. So instead of 0.1, I'll just reduce the voxel size. This will increase the resolution of our volume. So we have the 1 VDB, the surface volume, and I'll just do VDB to spheres. This is a really powerful node, and this is why I'm using the VDBs. This lets you pack spheres into the voxels of your volume. And if you use this max radius, we could reduce the maximum voxel size to use for a sphere. So instead of unbounded, then it just tries to put the biggest sphere it can fit into your volume. But if you limit it and then you increase the maximum spheres it's allowed to create, it might take a second to calculate this. Now it can pretty efficiently fill your volume with spheres. And we might want to disable overlapping. So what this will do is just allow these to sit very close together. So they're really nicely packed into the volume now. But because we're allowing the radius to be between 1 and 3 voxels, we get a nice kind of variation of sizes. And then I can middle mouse button here, and we see we have about 1,600 points. The last thing I'm going to do is add the p-scale attribute. So this copy to points, with our simulation, we had a p-scale attribute. And that's what this copy to points knows to use to scale or set the size of whatever geometry you're copying onto it. So now that we have the p-scale attribute, I can copy our grain model onto all of the particles. This is going to take a little bit of time to calculate. The reason it's a little bit slow is because we're physically duplicating and copying this high resolution grain particle, or the grain model, onto each point. So now we end up with something like 16 million points, or like 33 million primitives. You can see the memory consumption is taking like 1.7475 gigabytes. The original model is like 1 megabyte, but then because it gets copied and duplicated so many times, it starts to fill up the memory and just becomes very slow. Even the viewport, you could see tumbling around, is really slow to do. So if we go into the side effects documentation, they have this packed primitives section. This is a somewhat newer technique that they introduced in Houdini. You basically can use these packed primitives. We're just going to be looking at in-memory packed primitives. But you can use these kind of like instancing or referencing works in other software packages. It's a similar idea, or cloning, all that stuff. So basically what we've set up here very closely matches what this image illustrates. But instead of a tree model, like they're trying to make a forest, we're doing a grain model to make our beach, or our set of sand. So we took basically one grain model. It was like 1 megabyte or somewhere around there, and kept duplicating it, and it just kept adding up in memory. The file size of it kept increasing. So they're saying if you pack the geometry before you do all of your copying, all of those packed, the in-memory packed primitives will just reference or be linked back to the initial model. So this kind of works. A good way to conceptualize it is like thinking about a mirror, or like a reflection. So all of these links, that's why these are kind of semi-transparent, because you can't modify them, you can't manipulate them. The same way that a reflection works, you can move it around kind of compositionally. You can rotate it and scale it to make her smaller. but you couldn't change her hairstyle. You couldn't change her form. You couldn't make her a different person. It has to be relatively the same idea because it's referencing the source geometry. So just conceptually, it's a good way to think about this. Once you pack it, you're a little bit limited as to what you can modify on the geometry. So you can see it works. Our memory consumption is a lot lower. I can tumble around the scene really quickly and easily now. And we're just down to our one packed geometry. So this is kind of what I mean when I'm saying it's like a reflection. So if we just go to points, we can't grab individual points and make modeling changes. Once it's copied to all these, you couldn't deform and make little manipulations to the grain particles. You're just stuck with the base, the input shape. So it's kind of like a mirror or just reflecting. They're all linking back to that source input model before we packed it up. So it's pretty cool. We have them filled up, and then we have a little bit of variation using the p-scale. So because these source spheres we did between 1 and 3 voxels, we get a little bit different size variations. One thing we kind of can keep changing is if we go back to the side effects docs, they have another page that's really useful, is this copying and instancing point attributes. So this list of attributes is basically everything that this copy to points node will look for or supports when you're trying to tell it how to move or rotate or change the copies when they're placed onto the points. If you're just coming to Houdini and you're not too used to like using attributes and stuff like that, a good way to kind of conceptually think about them is if you think about shipping packages. So like this packaging label, it's kind of like all of these point attributes. It's just instructions to tell people the ship to location this is an address, but it's the same idea as this, basically saying copy it to this point or this location in 3D space or XYZ coordinates. So instead of an address, you just tell it what 3D coordinate to place it at. If we look at this box, it has you place this side up. This is kind of like using the normal attribute to tell it which direction to orient the copy at when it's placing it. And then p-scale is size. This packaging kind of has similar ideas with dimensions, depth, width, height, weight, and all that kind of stuff. So if we do want to make these variations, we could have like different orientations or different directions when they're placed. So right now everything's facing the same direction. It just looks pretty fake. It doesn't look very organic. So if I just use this attribute randomize node, you can see by default it's set to randomize the color attribute or the CD attribute. So I can just switch that to N. And right after I do that, you can see automatically this copy to points node knows to use this attribute, the normal attribute, to randomly rotate these particles. And for the distribution, you just want to change that to direction to get a proper like 0 to 360 degree sampling of different rotation values. So the next thing we might want to change is the p-scale. So I was already saying we get a few different sizes variations, but you can see because we started with a sphere and then like chiseled it away and stuff, these don't seem to be packed that tightly. So I'll just put this in, and we can switch this instead of CD, we can go to p-scale. And then right now, it's overriding or setting the p-scale to random numbers between 0 and 1. So instead of setting or overriding the value in this case, we can just multiply the existing or input values. And then this min and max value, instead of multiplying it by values between 0 and 1, if we do something by like 0.75 or 1.5, basically what that's saying is either shrink them down to 75% of their input size or make them 150% bigger, or randomly somewhere in between that. And then the last thing to be careful about is just this dimensions. Because p-scale already exists, it's okay, but you just want to set this to one dimension. So that's just saying to only use one component. For normal, you want it to be 3 dimensions because it's x, y, z. But p-scale, again, if we look at this, basically a float means one-dimensional. Float 3 is 3 dimensions, or vector is also a different way to describe 3 dimensions. So it's pretty cool. We'll just name these to keep ourselves a little bit organized. This is random direction. And then this one we'll just do multiply p-scales. So when you start copying stuff and getting pretty deep with these attributes, this randomize is really useful. You can just keep adding more and more of them to keep kind of sculpting or getting really nice fine control over your instances and get them looking exactly how you want them to. But it gets hard to kind of visualize or keep track of the attributes you're changing. So if we just go up to pane interface here, I'm going to set it to split pane top bottom. And then I'm going to go to this plus, and I'm going to switch it to an inspector geometry spreadsheet. So this way we can, kind of like Microsoft Excel or something like that, you just have a really nice list of all the different attributes on your geometry and the different values they are. So for every point of this input, kind of like every little shipping label, we have all the different attributes that we're describing. And then when we send that geometry to the copy to points, it looks at those attributes and then modifies or rotates the grain variant to match that instructions. So all these are just instructions that we're telling this copy to points node to use when it's copying the geometry, saying rotate it or orient it to this direction and scale it to this size. So it's pretty cool, but we're just using this one input right now. One thing that this copy to points supports with Houdini 18, they added it, is this piece attribute. So this is really nice. You can enable it. It's complaining right now, but it's basically saying, or what you can use it for is to switch between geometry that you want to copy onto the points. And you can supply a variant attribute on your template points as part of your instructions that you're giving it. You could say, use this first shape, use the second shape, use the third shape. So to get that set up, we just need to keep packing the rest of our grain variants. So if I just hold Alt and drag that pack node, I can make another copy of it. Just keep packing these other guys up. And then if I highlight all of them and put down a merge node, just highlight all of them again and connect it. Now we have our 5 packed geos all combined, all stacked on top of each other. So all of our variants are combined into one data stream, and then we can connect that to our copy to points. And again, it's still complaining. It's saying the piece attribute or the variant attribute is not an integer or it's not found on the target points, so it's ignoring it. And by ignoring it, it's just placing all 5 variants on each point. But if we create it, just name this variant, make this an integer, and you can see already it's just adjusted to using the 0 input number. Basically, we go over to this merge 0, 1, 2, 3, 4. This is what it's using for variants. So if I go over to my variant and adjust the value, you can see we're getting the different grain models that we set up. So that's pretty cool, but we're not able to modify these on a per point basis. We're just setting this value globally for all of the points. So we want to set this randomly. So just disconnect this, and again, do another attribute randomize. So it's, again, set up default as color. We want this to be variant in this case. We'll just do random variant. And then the dimensions, right now you can see it's creating 3 different components for variant, 0, 1, and 2. We just need it to be one value. And then this is still complaining right here, and it's saying the variant attribute is a floating point attribute. So floating point attributes, they just mean it has fractional values. An integer, that's what it's asking for, or what it wants it to be, is a whole number, like 0, 1, 2, 3. So it doesn't know what to do if you're saying like use variant 2.6. It wants you to say, just select, tell me 0, tell me 1, tell me 2. So we can just fix that. If we do an attribute cast node, just put that in. And what this does is lets you change the data type of attributes. So we'll do variant, and we'll move it to an integer. So you can see once we did that, we have random variance now between 0 and 1. So it's taking our floating point numbers or our fractional numbers and rounding them to the nearest whole number when we go between these 2 nodes. But it's just doing 0 and 1 because our random numbers here are between 0 and 1. So we want our variance to be between 0 and 4. 0, 1, 2, 3, 4. So computers always start counting at 0. We have 5 variants, but it's 0 through 4. It could be a little confusing sometimes. So our global scale, we can just set that to 4. So now our fractional numbers are going randomly between 0 and 4, and then when we cast them or round them to whole numbers, we have 0, 1s, 2s, some 3s, and some 4s. So now we have completely different variations. We're using all of our 5 different grain models that we created. I'll just get rid of that attribute create. Then I'll just say this, we're rounding variance to a whole number. And if we go back to this random variant, one thing we can do instead of continuous distribution, we can do a custom ramp. So this is really cool because you can use this ramp to change the distribution of variance. So if I go move this flag around and just have this really low number there, you can see we're mostly getting just, look at this, mostly variant 0. A couple 1s, maybe as this ramp goes up at the end, just a couple 2s and 3s and 4s, but mostly 0. And then if I go the other way, you can see we're mostly getting the variant number 4 model. So as you're thinking about distributing these grain particles and different shaders and stuff like that, maybe the majority of your sand kind of has these colors, and then a few of these more eccentric colors, or a few of the different kind of things just get scattered around, sprinkled on top, just to give it some pops or some interest. But I think the majority of sand, you want it looking kind of beige, or you want maybe very typical shapes. And then a few variants you can use this slider for and have control just to give it some variation. But the majority of your shapes could be kind of one typical sand grain shape. So it's pretty cool. I think we're ready to start dialing in some shaders. We have our shape grain instancing, kind of copy and pack primitives setup going, copy to points, and very controllable using all the different ramps and ranges and stuff like that to dial in the final look. Now we're ready to go ahead and start assigning some shaders and stuff like that. So before I get started with the test renderer, one thing we want to change is we want to move the render flag over to this output. So if I just hold down the T keyboard key, click on this node, we should be good to go. There's one more thing we need to change on the geometry container itself at the object level. And under particles, we no longer want to render this as particles. If we go over to the settings tab and then under instancing, we can say instance SOP level packed primitives. So this just tells Redshift to use these in-memory packed primitives at render time and maintain kind of the same efficiencies that we set up to avoid memory usage spiking or being too high like we were getting before when we manually like brute force copied these without packing them or doing any optimizations. So to carry this optimization through to Redshift, just make sure you have the instance SOP level packed primitives box checked. And then if I go to Redshift, can get our render view back. And we'll just get going with a test render. You go back to our camera, jump into the camera here, and I'll just lock it to the view and kind of home the scene. I'm just going to move this around till we get a position that's a little bit more interesting, get the light kind of hitting the edge of it. I might go into our light. We might just want to turn it off for right now in terms of the map, and maybe just start with a white default setting. So just for judging colors and shaders and stuff like that we create, we just don't want to deal with any color being introduced by the light itself. We want to just be visualizing the pure kind of like occlusion, or this is just like a very minimal studio setup or something like that. And then if we go back into here, the Walkman geometry object, what I'm going to do is just make a material network inside of here. I'm doing that inside of this network instead of going up and going to the material context or something like that, because once we get this all set up, we'll just be able to package all these nodes up and move them around into a different file if we want to preserve our entire little grain instancing workflow. So we're kind of making a little reusable tool or area of the network that's more transportable if we need to reuse it. And then I'll just go inside, and if I do RS material builder, this is the holder, and inside of it is your Redshift material node where you would assign all of the different settings. So I'll just hold down Alt and click and drag and make 5 copies of these. Each copy is going to be a variant for one of these packed variants or the different grain shapes that we've made. And we can just assign them using the material node and just put it right before you pack it. We want to assign the material at that step. And then if I click under the material linker over here, then we can assign the Redshift material from the material network. I'm going to do relative path. So this just keeps it as a relative file reference instead of an absolute path. So it keeps everything, again, more transportable. We could just highlight everything, copy paste it to a new file, and we don't need to relink any expressions or anything like that. So I can just hold Alt, drag this over. We just want this one going to the second material and the third and then the fourth and the fifth. And then I'll just restart the render over here. Sometimes when you're moving nodes around inside of the network, the render kind of messes up and you just need to restart it. So if I go up to the first material, we just do something, change. You could see we already get the visualization kind of in real time. So it's really quick to adjust these settings and see what you get. What I'm going to do is just go something kind of beige and just start by making a standard kind of sand material. Maybe get some more kind of oranges in there, and maybe just a little bit brighter. So this is going to be a generic kind of sand grain, we could keep an eye on some of the different references and stuff like that. We're kind of somewhere in one of these territories or something like that. We could just close out of the color picker. We might want to adjust this IOR. Basically, the higher you increase it, the more reflective or the more metallic it becomes. So maybe something 1.7, just to get it a little bit more highlights and start to see some of the edge detail and stuff like that as you increase that IOR. So with it too low, it will become very diffuse, just like a clay or something like that. I could even just make a snapshot here if we really want to compare side by sides. And then if I go up to kind of what we were at next, as we switch between these, you can see the difference. Just a little bit more reflectivity. I could turn off those thumbnails for now. I think we might want some roughness in the reflection. So it isn't just a perfect mirror. This simulates like some microsurface detail or surface roughness. Instead of perfect reflectivity, the reflections become a little bit blurry or like scattered kind of. So this should be a good starting point. We could go on to the next material, and maybe this one, instead of the beige color, maybe we want to do like a pastel green or something like that. You can see this is already updating. Looks like this is maybe a little bit too saturated. We don't want it too jarring or too eye-catching. Just something that you notice eventually staring at it long enough, but we don't want it to immediately stand out as like a very bright, odd-looking color. So something like that seems pretty good. You might go higher again with the IOR, and again, something pretty rough. There's just some variation in the specular responses. These might be made out of different materials. Some might be made out of a rock. Some might be made out of clay, glass, something. Just different little material responses. Different minerals and different types of rocks have different specular roughnesses and different IOR responses. So we're ready. We could just keep going to the next one. This one I might do maybe something a little bit more reddish, orangish. Just a little bit more earthy or something like that. And this one I think as well, we'll just add in a little bit of roughness to it. And we could just leave the IOR where it is for this one, I guess. We'll keep going. This one, we might want to do it more like a glass or a mineral or like a crystal or something like that. So you could get started with this tinted glass preset. And you could see what this does is makes it kind of like glass that has a absorption color to it. So as the light passes through it, it tints it or changes color. And that gets set at the bottom here with this transmittance drop down. And maybe instead of red, we want to go more into blue or something like that. So going back up here, it's just seeing some are a bit more white, some are yellowish, some have some bluish tint to them. So that's why I decided to move into blue. The higher your absorption scale, the more light it will catch. And then as well, could play with this scatter coefficient, maybe add some color and scatter intensity into there. So you might back off of this a little bit. So just finding a middle ground, something that doesn't block or change the color of the light too much. This scatter scale is like you add it in and more light will be absorbed as it passes through. So it's kind of like internal darkening with the scatter scale. And we might want to do some roughness up here again, so it's not just a perfect mirror or sharp reflective surface. So maybe something like 0.5. And the last one, we could keep going. This one we'll do another tinted glass. And instead of red, we could do something in this bluish territory. This one, just gonna start the preview again. So you can see this one, we're getting it, it's this like cyan aqua color. Maybe this one, we just don't want it to be as saturated. We could go even lower with the absorption scale, and maybe with the scatter coefficient, just add some extra internal kind of coloring. This is kind of like internal shadowing. Basically, it's like some murkiness or just something inside of it that's blocking the light with the scatter scale. And I think we're good. Some of these we might want to make the IOR a little bit higher. Basically, it gives you the default as like a glass, but if you go higher, you're more like a diamond or crystal or something, some more expensive kind of mineral or something like that. And then this color right here is just looking a little bit too close to the one we already defined. So I might just go into the yellow, orangish territory with this. And then we'd probably want some more roughness again, just so it's not perfectly reflective, something that catches more of the light. If you have the roughness too low, it can flicker a little bit with the highlights, as the edges are just really sharp and bright. So we want it to be a little bit more rough, especially if we're saying that this is sand grains that have been rolling around in the ocean or knocking up against each other and all that. And then I'm just going to go back to this previous one, and I'm just going to decrease the absorption scale as well, so it's not as eye-catching of a material. The blue was just a little bit too saturated and standing out a little bit too much. I might go lower with the scatter scale as well. So something like this could be a good starting point. One thing we can do if we want is go all the way back to our VDB from polygons workflow and just reduce the voxel size. And this is going to pack more spheres into the volume or into the voxels. And we can just do this to try out different shapes, different sizes of grains. It's going to take a little bit. It looks like it just finished cooking. So now I can render it again. Now we can just test a little bit more tightly packed sand. So it does look like this kind of greenish one, I'm seeing it a little bit too much, and then the reddish one, I think I'd like to see that one a little bit more. So if I just switch these material assignments around, you'd see as we do this, the render just isn't prepared for it. So we just make those changes and then refresh the renderer, and now we have a little bit less of the green ones and just more earth tones. So this probably is going to make the sand feel a little bit more natural. You'd make that change by switching the materials around. You could also just go into the variance, and if you change these sliders around, you could get different distributions. So with it the way it is right here, we're getting the majority of them as either variant 0 or 1, the first two right here. And then as that ramp moves up, we're getting less of the middle ones, and then probably a good amount of variant number 4, or this one at the end with the crystal kind of one. And I think if we want to, we could go back to our sunrise. Looks like we just have to refresh the render. Now we can test it in the scene. So this sunlight adds a good amount of warmth to our colors. That's why I just wanted to dial them in with an unsaturated light, basically without any saturation or color, just to see what we were getting before we... Sometimes if you set up colors with a super warm light source like this, you can bias your colors to be a different setting than you would expect them to be. I'm just going to make a few adjustments to the Redshift render settings themselves before we move on to rendering our character. So if I just go to the out network, this is the render network, this is where our Redshift render ROP is, and this has all the settings for Redshift on it. So we go to the Redshift tab, and under global illumination, the GI engine, global illumination is like indirect illumination. So I'm just going to click the plus button here and increase the GI engine to brute force, and the GI bounces. We'll do another test. So global illumination is like this kind of spill lighting, the color spilling onto the other geometry. Without it, everything looks a little too kind of contrasty. It doesn't look as photoreal. When the light hits a very like saturated color, basically it should reflect and bounce and kick some of that light onto other geometry around it. So you'd see with the brute force GI engine enabled, it's doing a better job at doing kind of producing that result, just looking more photographic overall. The next thing we could do is under system, we might want to turn on the enable automatic sampling. So what that does under settings here, instead of explicitly telling Redshift the min and max samples to use, it will automatically adapt to the number it needs to use to resolve the error threshold. So if we do a bucket render, it will ignore your min and max sample settings and just adaptively set those to meet the error threshold, or basically render the bucket until the noise is reduced below this threshold setting. So now we can just control the render times or the render quality with a single slider, and we don't have to worry about hitting the min or max samples. This is a newer feature in Redshift. It's pretty convenient. The last thing I'm going to change under IPR tab, I just want to turn on IPR live SOP level updates for deformations, volumes, instances, and proxies. So this will let us scrub the timeline or just work more interactively. Redshift will always be updating and getting changes. And now if we just take our initial nodes here, the VDB nodes, we were just doing this to set up kind of a template shader ball, like a little grain ball, sand ball. We could move this input and just move it all the way over to our character. So if we look here, we have the character running through our variation process, adjusting directions, p-scales, and variant and all that. We could go all the way to copy to points. So the viewport is pretty slow to display all these different instances. And one thing we can do to speed things up a little bit, we might want to just do a poly reduce. So if we look at one of these grain geometries, for example, we can use the poly reduce to kind of optimize this shape. So maybe something like 10. Because we're rendering these grains as so small, we don't care too much about the surface detail, but just more the silhouette and getting some different things jutting out. So you can see it doesn't change the silhouette too much, but we go down to like 78 kilobytes or 1,000 points from something like 10,000. So this is an optimization that should help Redshift trace rays against these surfaces a little bit faster if it has less surfaces to intersect with. Even though we're already doing instancing, that's like a memory management thing. Having less polygons or less surfaces does still help produce a faster render in the end. So I'll just put the reduce onto all these instances. You can see, even after we do that, The viewport should be a little bit more interactive, like it can display a few more of these shapes and it can tumble around a little bit quicker. But if we want it really kind of high performance, what I can do is move the flag to just visualizing the particles. And then if I hold down the T keyboard key, then we can render the final instanced or copied packed primitives. I'll go up to the object level. With this camera, I think we want to change the aperture and focal length. So with the aperture, this is like the sensor size. If you work with DSLRs or things like that, traditional film or any of that stuff, 36 is like a full frame sensor with a DSLR camera. And focal length right now is a super wide angle. So this is, once you set this to 36 for the sensor size, now the focal length is like a traditional camera lens measurements. So if I go to 55, this is like a standard, somewhat standard like portrait lens length. Sometimes I like to go a bit higher and just flatten out the perspective lines a little bit more. It just gives you some more interesting compositions, I think. So I'll just hit this preview render again. We'll see what we get. So it takes the renderer a little bit of time to create all of the instances and kind of move them around in memory and all that stuff. Even though we're working in an optimized manner, it's still to render something, I think we're around like 1,500,000 instances. It can still be a little bit slow. And I might just punch my camera in a little bit for right now to really look at the detail up close. It looks like we have some grid, these straight line artifacts. This is from the method we use to fill the character with grains, but it shouldn't be too much of a problem. I'm just going to do another snapshot. And what we can do is just, like we were adjusting the p-scale by multiplying them by smaller and bigger numbers to get some variation in the p-scale. We can do a similar thing to the position if we just use this point jitter node. So we don't want it to change the normals. We're using the normals for directions and we don't want it to change that. But if we just put it in the chain now, you can see with the size, what's happening is it's just adding a random displacement or blurring the point position. So we don't want to get him super fuzzy, but just a little bit should kind of help fix that issue and smooth out those results. So maybe 0025 is, you're still seeing a little bit of regular kind of lattice repetitions. Something maybe like 0.0045, it's less noticeable. So I'll just hit this preview again. So I'm keeping snapshots just to do comparisons between the two changes we make, just to make sure things don't get too out of hand. Now we can see we're able to fix that artifact or hide it. Everything looks a little bit more organic and randomly distributed. Instead of this is very like machined and inorganic, and it just ruins the look or the feel of sand. You never see sand this nicely organized into this kind of lattice structure. One more thing I think we do want to change is just that these, you can kind of see that there's little gaps between the grains of sand. So to make it look a little bit more like they're stuck together, or like wet sand, or they're clumpy together, if we just go to our multiply p-scales, under global scale, this kind of acts like a global multiplier to the size of the particles. So 1.35 will basically make them 35% bigger, or like 135% instead of 100%. I'll just do another preview render. It takes just a few seconds for Redshift to update, because we're rendering so many instances. we can see now stuff is sitting together a little bit better. It's looking more like that grain ball. So we solved not only this rigid, repetitive structure, we also made the particles bigger just to make it look like they're stuck or pushing up against each other. And I think we can move the camera back now. Just going to the full body kind of composition or something like that. One of the things with this desert, because this is a HDR, like he's never going to feel this integrated. This is just a backplate. It doesn't actually kick light up or shadow things or anything like that. This is, like I said earlier, this is just for trying out different looks, different times of day, different locations and environments. Or if you did a shoot on set, you can use it to recreate the lighting conditions, but you would still want to model a lot of the geometry to fill things out. For the case of this tutorial, I'm just going to get rid of the HDRI and just make some Redshift lights. You could add the Redshift shelf like I did up here. If you just go to shelves, you'll see the Redshift under this checkbox. So what we can do now, I'm just going to unlock the camera. I'm going to add a light from this angle. Just control click and you can add a light from the viewport position. I'll add one more from the other direction. So we'll kind of hopefully have a rim light with this one. And then I'm going to control click and make another light. And this should be more of a fill kind of light. You could pin the viewport to the light and then move it around like you would a camera. And that's a pretty nice way to move your lights around. And we could just do another render now and see what we get. So this is working more like a photographer would in a studio. With these rectangle lights, these are like little box lighting a photographer might set up. So you can really control the shape of the lighting and shadows and stuff like that and really show off a lot of the detail and clumps and like material of the shaders and the simulation results in general. So this second light is feeling a little bright. I'm just going to cut the intensity in half. And then the first light we added, I'm going to boost the exposure. So the exposure is nice. It's working like in stops. So if you're used to working with a camera, this is like going up or down in exposure with stops. Intensity doesn't work the same way. This is a linear scale, so you have to use a lot bigger numbers working with intensity. But this is starting to look more interesting, more dynamic to have the contrast in here. But just having him on black doesn't look that grounded in reality. I'm just going to make a grid, something for him to stand on. We could actually go inside of this grid. I'm going to turn on all the other objects. And if we do a bend node, this will let us curve the grid, kind of like a photographer would fold up a backplate. With this capture direction, if I just do -1 instead of 1, we can flip the bend direction around. And you can also change this capture length to choose like where it's creasing and the angle of the bend. Like now it's a lot softer of a bend. And with the grid, I might want to make it a little bit bigger. And if you increase the rows here, this will just give you more subdivisions. You could as well also just add a subdivide node at the end to smooth the results so we don't see any hard creases or anything like that. So we'll go back to the camera and just do another render with the grid in place. So because we're using GI, we should see the grid reflecting some light back up, and the character should be a little less contrasty, should have some more fill light and stuff like that hitting his body. And if we want to control the material of this, we could just go into the material network make a RS material builder. So I'm keeping this separate from the other materials we made. So the other thing, I'm keeping it together so they're all kind of in a package, but this one is just a generic kind of material that doesn't belong with the sand grains. We might want to change, maybe it's not as bright. If we make it a little bit darker, we're just making your eye look at the character before the backdrop. We might want to increase the roughness. So without any reflection roughness, you can see it's acting like a perfect mirror. It just doesn't look like that. It's like he's walking on glass or something like that. If we make it rougher, then you'd still see a little bit of the reflection, but it just makes it, this is like a rougher material that he's walking on. Maybe like 0.35. And then this IOR right now is like a glass. We might want to go lower. Something like this is closer to paper that a photographer might use to lay down for the character. And then with these lights, I'm just going to look through the first light we put down, pin the view to it. Could maybe even go up higher with the exposure. So this way we're really getting a hot kind of rim light, really showing off the form of this character. And the light is shadowing against the backdrop we made. So it's casting this interesting geometric shadow that's kind of with the line just leading your eye right into the base of the character. So that's pretty cool. I might just look through the other light, and with this one, I'm going to point it a little bit more towards the backdrop, and we might want to go up a stop of exposure. We're starting to see it there. And what I want to do with this one is just get some more play happening on the backdrop there. So it's not going completely black or dark at the edge. It just makes things look a little bit more real when you can tell that there's more than one light source. Like this is just going to be a little kick kind of light. Maybe go up one more with the exposure. You can also adjust the spread if you want to. This is like opening or closing barn doors on like traditional photography lights. So it's focusing the light more directionally and making it like, this is more diffuse. It's able to go in every direction. And with this spread, you can really make a beam and kind of focus it to hit a very specific area. Sometimes when you decrease the spread, it does make the light more intense. So you have to go down with the exposure. I'm just going to move it around a little bit more to see what happens. So this is starting to be kind of cool. I think it's nice to see some contrast. Before, when it was hitting too much of the front of him, it was just like flattening everything out. I think this is starting to be a little bit more interesting. Might just go down, control the spread a little bit more. And then one more thing we can do with these lights is maybe adjust the color. If you look at the color editor here under T, this stands for temperature. And with lighting, this is pretty important. So we go this way, and this is like incandescent light, or a lot of indoor lights kind of go yellow. Like fluorescent lights are a bit more blue like this. I think the blue adds a little bit more like kind of professionalism. A lot of photographers use pretty expensive lights that kind of have this cool color temperature to them. So I might just stick with the blue color temperature. And everything's starting to feel pretty nice. We're actually rendering, let me take a look. we're just doing 1280 by 720. Or we could go up to HD, 1920 by 1080. And under our out network, right here, if we wanted to, the color or the frame range, could switch this to the entire frame range. And then this way, if you did render to disk, you would get the entire shot, the entire animation, instead of just a single frame. We could also go to the air threshold or the noise threshold. I'm just going to increase that to speed up the render times a little bit. And you could do another bucket style render. So with this air threshold higher, we'll get buckets that finish up quicker, but they might have a little more noise in the result. But just for working quickly, it might be a little bit better to do that. So you can see we're getting really nice variation with the sand grains, the different shaders and the different shapes. It's just making things feel very photographic, very realistic. You can click on this gear. When you get to like the finaling stage of things, it can be nice to start doing this photographic exposure. So with Redshift, this applies like tone mapping. You can see with this, I'm able to more easily manage the highlights. If I want to roll them off so they aren't clipping out as much, you could decrease the allowed overexposure. You can also change the f-stop. This is like your global exposure, how many stops you are. The saturation is nice if you want to just boost things. This is kind of like some quick color correction settings. Instead of bringing this into Photoshop, After Effects, or your compositor or whatever, it's really nice that Redshift gives you these controls to make quick color corrections and just try out different looks. You can really dial in things without having to leave Houdini or Redshift and go into another software package to do like post-production. So it's really helps you work more quickly. So this frame's feeling pretty cool. I might snapshot it. I might go forward in our scene. You go back into the camera to just see what frame we're on. And I might do another bucket style render. So just evaluate how the lighting hits him, because we're not using the HDRI anymore. As he moves across the scene, the lighting on his body will change. So HDR lights, they're infinitely far away, or because it's a dome, as he moves around, the lighting doesn't change as it hits him. But with these grid lights, or the area lights, as he moves through the backdrop or through the environment, you'll see more of his body come in out of the shadow. So it'll just add a lot more interest to the simulation. You can see we're showing off a lot more of the clumping detail with the shadow, just a lot more definition and detail using these more photographic style area lights instead of relying on the HDRI. So again, the HDRI is really nice for just trying out locations, environments, or times of day. But then to really dial in results, I find that you kind of want to either recreate the HDRI or just start with like a photographic studio environment. And then you're able to really get the shadows looking the way you want, shape the character, and really control how the viewer's eye just uncovers or realizes this motion. Just really have a lot of control how they interpret what's going on. So that's going to be it for me for this one. Thanks everyone for watching. Before we wrap up, I just want to share the final results. So I took some time to render this offline. Took maybe 10 or 20 minutes a frame. I was actually rendering this at 4K just to upload it to YouTube. I kind of wanted to see what happened, and I wanted to really highlight a lot of the little intricate details for all the time we spent setting up these instances. So even in a nice like high resolution print, you should see a lot of detail. The other thing I wanted to make a quick note of is just with motion blur. That was one thing that I added at render time. So if you want to set that up, you just go to your Redshift drop in the out network, and then under motion blur, just enable motion blur, and enable it for both mesh deformations and instances particles blur. So our topology doesn't change from frame to frame. So what this will do is just over the duration of the shutter, the camera shutter for each frame, move the particles from their current position to the next frame's position. And then you'll get some nice photorealistic kind of streaking kind of happening. So it's a nice detail just to add. If you don't have it, things can look a little too sharp in different areas, and just the motion, it looks more like a stop motion animation or something like that. So I think it's a really cool feature to turn on at the end for your polished, finished product. And one more thing I wanted to talk about was just how reusable this setup is intended to be. So again, like I was saying, we started testing it with this VDB from a sphere, and then going back to VDB to spheres to make a bunch of little rocks or little particles inside of that sphere. So basically this whole network over here, from here to here, can be wrapped up and almost thought of as like a tool. So if I just wanted to use this as a new project, or you have a new concept from your art director or something like that, maybe we'll just do this as an example and say sand for our font, and just switch it to Helvetica. We can do a poly extrude, and what I'm going to do is just very quickly fill this text with sand. So we'll just cap the back of it, and if we do match size, then we can quickly just move it above the ground plane. So justify Y, you can just set that to minimum, and that will set whatever input geometry to be above the ground plane. And then I can just pump this into my network here. We're going from sand, and then we're going to VDB particles or VDB spheres. Maybe we want a little bit more spheres, pack this font full of grain. So basically, whatever we output from here, we might want a little bit more detail. Whatever we output from here, just particles with p-scale, that's all we need to feed into our workflow that we just created. And we'll have a nice system to set up sand instances. So it looks like this VDB for 2 spheres is a somewhat expensive operation, just to figure out the penetrations and stuff like that. It takes a little bit to resolve it. But now we should be all set. I could just put my display flag there. We have our sand, maybe take the camera, reframe everything, get a nice composition. And then if I just go to Redshift, open render view, you can see we're already up and running with a pretty interesting result. So just keeping this network around, you can even just copy and paste it into new Houdini files with Control-C, Control-V. That's a really nice workflow to reuse stuff. You could go down a route and just package this up into an HDA or a Houdini asset and make a reusable tool that you can bring from scene to scene. Anytime you need to make sand, you could just apply this to it. All right, so thanks again for everyone for watching, hanging through the whole hour and a half. I hope you learned quite a bit, picked up some interesting tools and techniques and stuff like that. Had a good time at least. So I'm just gonna take this second at the end of the stream, or the end of this recording, to thank everyone who's subscribed to me on my Twitch channel. So if you just go to twitch.tv/JohnKoons, I do Houdini live streaming over there, little workshops and demos and stuff like that, and got a nice little community going on. People subscribed over there, does a good job of supporting all of the Houdini stuff that I do. Looks like my thing changed. All right, so I have a little script here that I was using to thank everyone. So we have tier 3, the God tier. The top tier, subs, Extradite, Jabram, the boss, the Hulai, undisputed champion, undefeated, Mistaken Tuna, Avatar Sofve, HD3Z, Elepangusha Much. I think I said that right. Iliuad, Rise VFX, Belkin Design, Long Walk Dathan, iBumbat, Z8 Editing, MKI Alex, Dubtronics, Veganuts, Ilu, Cyberslane, Huckleberry Finn, Noranjos, P2 or underscore, Shades of Orange, Bast, It's Terrific, Shakin Kosi, Tunicorn, Peter Galliard, I'm That Guy Brandon, the top gifter. This guy gifts so much you should be calling him Santa Claus. Stray 9 Lead, I am Sean Sullivan, Ruby Yachts, Diener Daddy, Steve GH. This man put me onto the polyfill trick. Stasha, DJK Design, Black Ruku, Julian Loescher, Halo 1 Mike, Player 2, Gurad, Chris Arn, and DeBello. Thanks everyone for supporting me, subscribing over at twitch.tv/John Coons. Every bit of subscription contribution helps give me more time to spend producing this kind of educational content. Allows me to spend more time doing what I love to do and just sharing Houdini tricks, tools, workflows, and all that kind of stuff with the community. The more people subscribed, the more people gifting, the more people doing all the bits and the Twitch nonsense helps me just spend more time and produce higher quality content, buy better recording equipment. This mic sounds kind of scuffed right now. One day I could get a much better one with some more subscribers. So hopefully you guys enjoyed this tutorial. If you did, please head over to twitch.tv and subscribe. If you're an Amazon Prime member, you can link that to the Twitch account and then use that to subscribe to me, and that helps me out quite a bit. So thanks everyone for watching. Thanks everyone for sticking through to this ending portion, the begging portion. I appreciate it. I hope you had a good time and learned a lot.